Welcome, everybody, to week 13, day one. Today, we're going to be talking about one of the most important topics, one of the most important concepts. Get on the putty, Shinji. I had a student in the 12 o'clock section today come in dressed as Shinji. So I put on sunglasses, pushed it up, and did the thing while I said, "Get to the whiteboard, Shinji." So we're going to be talking about one of the most important concepts in computer science today, which are classes. It's the last major topic we have to talk about. There's a couple minor ones. Pointers we still need to go over and some other stuff, but this is kind of like a big topic. And in fact, a lot of CSI 40 classes start with it. If you were to be taking this class in Java, they would usually start you with classes. And we don't, because you can actually write every program known to man without using classes. However, they make organizing your code a lot easier, a lot better. So what I'm going to show you first is the problem that they solve, and then I'll show you how to solve it. So let's come over here, and I got this beautiful background. Thank you, Microsoft, for having a nice template. And let me show you the problem that we are going to solve. So let's say you're going to be loading a lot of data, right? And we've done this 2-3 times now. You load data from a file, for example, the CSV files. You read a row and you split it. Or you just be reading from a file like the Japanese to English dictionary, where you read an English word and a Japanese word. You have to pair them together. For this example, we're going to pretend we are part of the Social Security Administration, and we're going to be reading database like a text file. Instead of having a real database, we just have it all written to a text file. And we're going to be loading data on people. And so we are going to be, the basic pattern for doing something like that is you go into an infinite loop, you keep reading data until an error occurs, then you stop. About it. It gets a little dicey, though, when you've got different things describing the same person, right? So if you're just reading one name or something, like, that's not hard to deal with. But like, let's say that every person has a name. Maybe they have a first name, they have a last name, they have an address, they have a social, they have an income. There's all sorts of information. For this example, we're just going to have 3 pieces of information on them. Each person is going to have a name, an address, and a social. And you're going to be loading them either from a keyboard or from a file. It's essentially the same code. But this gets kind of annoying, doesn't it? And in fact, on an earlier assignment, one of my students is like, "I've got like 5 vectors holding all the different pieces of information about each person. Is there a better way of doing this?" And the answer is yes. That's the topic for today. Okay, so you can make it work. You can make it work with this. You got code like this, right? You go into an infinite loop, and you read the name. You check to see if there's an error. And if there's not, you add it to the names vector. You read the address. You add the, again, you'd want to check for an error. I just kind of ran out of room on the slide here. If there's no error, you add it to the address vector. You read the social. You convert the social from a string into a long, or technically, I think you can hold in a social in a integer, but I feel safer with a long. I don't like having my numbers kind of creeping up on my maximum value. Like the biggest social we can have right now is 999,999,999, and that's very close to the limit of an integer at 2 billion and change. That doesn't make me feel comfortable. Unless space really is a concern, I'd probably store it into a long. Do you guys understand? 64-bit integer signed. I mean, you can't have unsigned integers, but it doesn't really matter. Space is cheap. I mean, if it's not, I mean, it's a trade-off. You could probably convince me to hold it in an integer. I feel very uncertain when my numbers get, like, if you're making a video game and you're like, the score of a player should never exceed 2 billion. I'd be like, I don't know if you should be using an integer. And they're like, well, we've done the math. It can go up to 1.9 billion. I'd be like, yeah, I don't feel good with that, because just the slightest change. You add one more level to the game or something, their score exceeds 2.1 billion. It overflows, and it's now negative 2.1 billion, and people get mad at you. And if you're only holding the score once in your code, we're talking about an extra 4 bytes of RAM. We can afford that these days. It's not a big deal. Um, if you're talking about the entire Social Security Administration, you're talking about 4 bytes per person times 330 million people, which is 1.2 gigs. You know, Hmm, you know, you can hold that in RAM pretty easily. Hard drive space, negligible cost. I mean, like I said, you could probably convince me that should be an integer, but anyhow, I'm using a long long. So we get line a string, and we convert from string to a long long, and we add that to the social. So now, if we're inputting information like this, the user types in Bill Kearney, my address, 111 Main Street. Please don't come and egg my house. Here's my social, 1234567. Don't dox me, people. We type in Mason, whose address is 666 Underwood Road. His social is 666 Ben Bohan is at 42 University, now professor, with me and all this. Don't dox him, man. His social security number is 42. Do you guys understand this inputting system? Like, basically, over and over again, you read a name, you add that to the names vector. You read an address, you add it to the addresses vector. You read in a social, you add it to the social vector. Do you guys understand this code pattern? This is what we've done so far. We have not learned anything new yet. Okay? But I think you can see how this is starting to get kind of annoying, right? Like, having to make, like, if you have like 20 pieces of information about somebody, like you got your gender, you got your ethnicity, race, which is different from ethnicity in America, um, uh, preferences of whether they drink Coke or Diet Coke. Like, you could store a lot of information about people. You would need like 20 different vectors, to hold 20 different pieces of information about each person. And then keeping them synchronized is going to be really annoying, right? So, like, name.at0 is my name, address.at0 is my address, social.at0 is my social, and then entry 1 on all of these guys holds the different pieces of information about Mason Twanta, and then Ben Bohan's information's all at, row 2. But what if somebody deleted, like, Mason's address? What's going to happen? You got a million people in your database, and you delete address.at1. What's going to happen? Gonna desync. Everything shifts. Yep. Everyone with an address of 2 or more is in trouble. Yeah, nothing makes sense anymore. Mason's gonna have Ben's address. Ben's gonna have whoever's next to him's address. Everything is now no longer lined up. And that's super annoying. Now, would you delete something like that? Probably not. But what if I sorted this vector here? What if I sorted, which is something you do. Give me the list of everybody, in America sorted alphabetically. Give me everybody in the database sorted by last name, sorted by first name, sorted by social. This is something we do. What happens if you sort just the name vector? What's going to happen? Are these guys going to get sorted the same way? Nope. Now everything's broken, right? Because you no longer know whose social is paired with what name. And there's not even like a really easy way of like sorting the address and the social vectors the same way, right? Like you can, like, I can think of like some like, hackish kind of ways of doing it where you create like a pair, and the pair holds the original index, and then after you sort it, you like grab the second value out of every spot, and then like it would just be this horrible nightmare to do it. And that's actually something that you see very commonly with inexperienced programmers. They will invent these solutions that are like really complicated, and like the kind of thing like an experienced programmer would go like, I don't want to do that. Like, how do you sort 2 different vectors the same way? Like, I don't want to do that. Like, that's really annoying. You know, why don't you just use a class or a struct, which is, again, the topic of today. Yeah. Yeah, that's a great GIF, Bean. Yeah, that's literally what happens when you try sorting and you've got different vectors holding information about the same person. It's just a nightmare. Okay. So it's going to break everything. Okay. So if only there was a better way. Only there was a better way. Everything breaks if you sort one of them. Okay. Here's the better way. So we are going to make, for the first time in this class, we're going to make a new type. Okay. And so a type in computer science describes what sorts of values a variable can hold. So integer holds positive and negative whole numbers. Float holds decimal numbers. Double holds double precision floating point numbers. Booleans can hold true or false. So what we're doing here is we're creating a new type. So instead of saying integer Bob, we could say SSN database Bob. It's a new type. And it's describing what sort of values Bob can hold. And in this case, we are saying it's going to hold a name, an address, and a social. The name is a string, the address is a string, and the social is a long, and initializes 0 if we don't give it a value. Strings initialize themselves to empty strings. So this allows us to do something like this, where we can say SSN database Bob, and we can even initialize it. Look at this, curly brace syntax. Remember, smart quotes don't work. You guys remember that from the debugging assignment? Smart quotes, this code will not compile if you copy and paste it. And that's a Greek semicolon. No, I'm kidding. Just PowerPoint being PowerPoint, you know. It's just one of the frustrations of putting code onto PowerPoint is that PowerPoint does its best to break it. So, you can initialize all the different member variables, is what they're called, on Bob by using this, what we call universal initialization syntax, by using curly boys, and then whatever is in the first thing before the comma is name, whatever is here is the address, and whatever is here is the social. So in the order that you declare it in the struct here is the order they get initialized. So if we have this, how do you access these sub variables? How do we get the name out of Bob? How do we get Bob's name? How do we get Bob's address? How do we get Bob's social? Well, there is something called the dot operator. The dot operator is how you grab the sub variables out of a variable. So we say Bob.name, and that is a string, and you can use that anywhere else you could use a string. Anywhere you had string S, you can say Bob.name, and that's a string, and you can use it. So if we see out Bob's name like this, what is this going to print to the screen? What string is it going to print to the screen? Yes. What string is Bob.name going to print to the screen? John Cena is correct. And is he eating ice cream? Who knows? It's you can't see him. It's just not possible. When my daughter was in kindergarten, she was fascinated with John Cena because one of her classmates, yeah, that's the one. One of her classmates told her, he's like, John Cena is stronger than a car. And so my daughter comes home, she's like, Daddy, is it true that John Cena is stronger than a car? I'm like, no. She's like, okay. Well, is he stronger than a pine cone? I'm like, yeah, probably. You could probably crush a pine cone. Probably wouldn't enjoy it, but yeah, sure. You probably do. And there you go. There's John Cena with the ice cream. So his Mandarin's not, yeah, exactly. And a car can also crush a pine cone, you know. So she's like establishing, like, it's very interesting to see, like, kindergartners like trying to work out these things. Like, okay, we got pine cone, John Cena, car. That's the hierarchy of life. Okay, so when we print out the fourth bullet point here, when we print out then me, that's exactly right. Yeah. I don't know if you guys saw this on the workshops channel. We went to Yosemite on Saturday. Yeah, there you go. So there's my bicep. So just, don't get too jealous, but this is what peak physical fitness looks like. You got 2 tickets to the gun show right here. What's it going to print out for Bob's address here? It's a bit of a trick question. Is it 123 Happy Street? Let me fix those darn smart quotes. They're bugging me. Domestic. Okay. Yeah, it's not going to print out 123 Happy Street because if you look at bullet point number 3, we're actually changing it. So do you guys see how this works? Like you can read the name of Bob, you can write the name of Bob, you can read the name of the address, you can write the name of the address. Like you can read and write to the variable just like you read and write to any other variable. So here, Bob's address was originally 123 Happy Street. Now Bob's address is 42 Foo Street. We overrode it. This value never gets used in our code here. And then we output it. Okay, last question. Screen was all pixely. Yeah, can you see it now? I can probably mess with the stream settings here. Oh yeah, it's on 1080p. Okay, let me do that. Okay. Can you go back one slide? Yes. So this is how we're describing every person. We're essentially saying every person in our Social Security database has a name, has a address, has a Social Security number. Now, the philosophy of has a versus is a and all this kind of stuff, we'll talk more about that in CSci 41, which I hope all of you guys are going to take. Just taking one semester of computer science is not good enough to really get good. Like it's you go over the basics, but like honestly, I think every person should take at least 2 semesters of computer science. And then after that, you can go to aerospace or whatever it is you're trying to do. So what value is Bob's SSN going to have on bullet point, what was that, 6 there? The very last line here, where we see out bob.ssn. What integer is it going to print? Or it's actually a long, I guess, whatever. What number is it going to print to the screen? Is CSI 1 the same time? Yes. CSI 41 is the same time as this class. And there's both in-person and online versions. And you can come to either, whichever works better for your schedule. I know a lot of people like math conflicts and things like that. So you're more than welcome to come in person after math. And the answer is not 4321. Because on bullet point 5, I got him. Bob.ssn gets incremented by 1. So bob.ssn ++ means that it has been incremented by 1 point. So when we see out Bob's social, his social is now 4322. Yep, no, that's why I asked the tricky questions. Don't worry about it. All right. Now you can make a vector of these SSN databases. Nice. So rather than having 3 different vectors for name, address, and social, we can just have 1 vector. And so we can do things like, say, vector.at 0.name, vector.at 1.address, vector.at 2.name. Like you can actually just access every variable. Every variable is like 3 variables in one. It's like 3 variables living under 1 roof is what a struct is. Okay. You might also hear me use the term struct in class interchangeably. That's because in computer science and in C++, there's one very slight difference that you'll learn about in CSI 41 between classes and structs. Classes are private by default. Structs are public by default. Other than that, they're all the same. Okay, same thing, same concept. So here you can see that we have made a variable named Bob. Again, initializing it with John Smith instead of John Cena. Terrible. And then we've added him to the vector. You see that? So that prevents us from having to have three vectors. We only need 1. Now, a good question is how do we sort it? And to that end, let's go to PuTTY. So let's go and fire up the Putty Mobile. We have system restart. Fantastic. Okay. So then let's see. Yeah. I'm sure there's nothing important in there. Okay. So what should we make a struct for? I'm going to need a name of something. By the way, struct, the syntax for struct ends with a semicolon. This is different from every other thing you'll ever see in C++. Classes and structs end with a semicolon after the curly boy, and that's weird. Everyone forgets it. There's a reason for it, and I can explain it in 41, but everyone forgets it, and don't worry if you forget it. The TA forgot it today. I forget it all the time. Everyone does. Superpower database, power level, a superpower database. Okay. So let's make a database of people in Dragon Ball Z. Okay, sure. So superhero or something like that, maybe. Okay. So what kinds of things describe a superhero in the Dragon Ball Z universe? What kinds of attributes does every superhero have in the Dragon Ball universe? Their power level, of course. Goes without saying. Now, is that a float? Is it a double? Is it an integer? Long? What is the maximum power level that you can achieve? Okay, a name, yeah. String name, sure. String species, definitely accept that. Over 9,000, I know, but like, what's the maximum? Like, anyone know what the highest power level is in DBZ? Has to go up to at least 50 million. Goku has a power level of 2? That doesn't sound right to me. $21,000, $39,000. Interesting. Yeah, it sounds like an int can hold it. Okay. Let's call it. I like snake case. A lot of people like camel case. And isn't there like Saiyan, like, what is it called? Like, you can go to like different levels of like Saiyan things. Okay. All right. So 2.5 billion. Okay. Then we will need a long to hold that. If 2.5 billion is a thing, then we need a long to hold Super Go Getta. All right. Okay, what else? Name, species, hair color, Saiyan, location. We could do something like this. Do like float X, Y, Z. We could do that. We could hold its location, right? But let me show you something kind of cool here. We could do struct vec3. Don't forget the semicolon. And we can have double X, Y, Z. And then its location could just be a vec3. Like that. So we can hold Goku's X, Y, and Z location. And then we can do other things like size, weight, velocity. We're making a video game. Times revived. Gender. Plot armor. Number of Dragon Balls in possession. Yeah, let's do that. Like, yeah. Okay. And Dragon Balls. Now, you can give these things a default name. Okay. My wife just got a letter from our daycare that we haven't been to in years, and her name was Null. So we can do that. Oops, deleted a little too much. Null. Power level of, I don't know, 0 by default. Location could be 0, 0, 0 by default. And the number of Dragon Balls is 0 by default. Okay, now all of your variables are initialized. Okay, so let's make some DBZ heroes. So obviously we need Goku. So superhero Goku. And we're going to initialize it using braced initialization syntax. Now, this is actually valid code. If you do this, it's just going to set everything to the default value. So his name's going to be null, his species is going to be null, et cetera, et cetera. But we want to give some values here. So what is Goku's name? What is his species? What is Goku DBZ backstory? Manga name. Son Goku. Race is Saiyan. Power level. We'll put him at power level 2 for the early Goku. His location. Yeah, this is why I was gonna. Well, this is why I was gonna take out the location. It's gonna add. It might break some of your brains. I don't know. And the number of Dragon Balls he has. Let's say he has a Dragon Ball right now. Okay. So if I were to see out Goku dot Dragon Balls, what is this going to print to the screen? And I'm probably going to comment out this because it's going to be a lot of typing to work with. Let's find out. Survey says 1. Right there is his DBZ count. Look at or Dragon Ball count. Okay. Now, if I try outputting his location, is this code going to compile? Can I output a struct? Can I see out a struct? Could I just see out Goku? Would this work? No. Sorry. C++ has no idea how to see out a superhero. You have to tell it. Okay. So we can make a print function. So we can do something like this, void print. That takes in a const superhero by reference named S. And we could see out S dot name. We'll do it like CSV style, comma separated value style. S dot species, comma S dot power level, comma. Make those single quotes. Okay. S dot loc dot x. It should be single quote. Okay. S dot loc dot y. S dot loc dot z. Close parentheses. And then S dot Dragon Balls. And there we go. So I can now call print on Goku, and it will print out all of his stats. You guys understand? So C++ has no idea what format you want things in, so you just have to tell it. I want the name with a comma, and then this, and then parentheses, and the location. You guys see how this works? And you can just grab any of the subvariables out of Goku. You can grab Goku's name, Goku's species, and then for the location itself is the struct. So we go 2 levels deep, and so we s.loc.x, s.loc.y, and so Could you do this infinitely? Sure, you can have dots inside of dots inside of dots. I wouldn't go that deep, but yeah, you can do something like this. This is fine. So I'm grabbing Goku's location, and in the location, I'm grabbing his X location. You guys understand the dot operator? Like I could, I don't know, change his Goku dot Dragon Balls plus plus. Does that make sense? You do not need to do... Yeah, superhero does not have a print function on it. Print is a global function. There is something called... so for those of you at home, he asked, could you not do superhero.print? But there is no... It's not a... This isn't Java. This is... There's no... There's a proposal in C++. That's probably never going to happen. People have been talking about it for a long time where you could do something like that. But yeah, you just call print on Goku. Print is a global function, and it takes a superhero, and so we're passing a superhero to it. Then it prints out all the stats on Goku. So when I print this out, how many Dragon Balls is it going to print that Goku has? What do you guys think? You guys are correct. He has 2 Dragon Balls now. And so it prints out his information in CSV format. Goku, he's a Saiyan. His power level is 2. This is his location. And if you're making a video game, like the location would update as he runs around. The XYZ coordinates are going to change. You know, you might have maximum speed. You could have velocity. There's a lot of stuff that you could add to this, but we're just going to stick with this. So let's add some more people. So who else should we add? Bulma. John Cena. Human type Earthling. Let's just go for human then. What's her full name? Buruma. Dr. Buru. What is her power level? Right, we have to ask the real questions here. What is the power level of Bulma? Power level is 16. All right, good enough for me. All right. And she'll be at Goku's address, and she's got no power balls. So now you can see that you see how this works. Like you just make new heroes, and we can make a vector of superheroes if we wanted. So make a vector of superheroes named Vec, and rather than doing all this stuff, we could just vec dot push back. You can add Goku. You can add Bulma. Thank you, autocomplete. Very cool. Let's add one more. Let's add 2 more. Who else wants to be in it? Would we always print out part of the string struct using S? Well, S is the name of the variable that I passed in here, right? So if I called this parameter here hero, then I'm going to print out hero.name, right? Makes sense. So hero is the name of the superhero being passed in. So we print out the hero, whatever hero it is that's being passed in. We print out its name, the hero's species, the hero's power level, etc. Okay. S doesn't mean anything. All right, so give me some more Piccolo. All right. He is a Namekian. What is his power level? 3,500. All right, cool. Actually, let me show you something cool. So rather than having to make a variable and then push it back and make a variable and push it back, I can actually do this. Vec.pushback, and I can actually use that universal initialization syntax, like I showed you, and actually pass the parameters in right here. So I don't actually have to make a separate variable for it. So, so his name is Piccolo. He is a Namekian. His power level is 3,500, according to the thing we just looked at. His address is at the world origin. Why not? 000. And he's got 3 Dragon Balls on him. Okay. All right. So give me somebody else. Vegeta. All right. So he's a Tuffle. Okay. Who is the cheetah? So he's a Cyan and power level. 18,000. We'll just go with that. I'm sure it changes, and I'll get angry comments on YouTube from this, but this is how we're spending our time in class. Vegeta is also a Cyan. Power level of 24,000. He will be at 420, 5.4, negative 2,000. And he'll have 1 Dragon Ball. Okay. Actually, his power level got up to 530,000. Now, if I wanted to print out all of the people in the vector, how should I do this? How can I print out everybody in the vector using a for loop? What kind of for loop should I use? Should I use a range-based for loop, a standard for loop? What do you guys think? While loop? What do you think? How should I print out everybody in here? For each loop? Yeah, that's how I do it. Okay, so I'm going to say for every const superhero reference hero. I don't want to call it S again. So for every superhero in the vector, we are going to call print on that superhero. Okay. Don't even need the curly boys. Curly boys are optional. This is something that keeps cropping up on the competency exams. Is that students think that you have to have curly braces. You don't. If you have one line of code, the curly braces are completely optional. It's just a style choice, whatever you think looks better choice. It does not affect the correctness of your program at all. And so there we go. So Goku, Bulma, Piccolo, and Vegeta Okay. So now the question is, how do we sort it? Because before we would have had like 5 different vectors before, and if you sorted the Dragon Balls vector, then it breaks everything. But now we can sort it because everything sticks together. You can't, accidentally move the name of one thing with the vector of the other unless you really, do so deliberately. So how do we sort a vector of superheroes? And this brings us to the other major topic for today. So we are going to make a function called sort by power level. Let's do power. That's more interesting than name. Sort by power level. I'll have you guys write sort by name for your lab time. And this is going to take in 2 superheroes. So we are telling C++, how do we want to compare superheroes? Because it doesn't know, should I sort based on the name? Should I sort based on species? You have to tell it. So I'm going to write a function that will sort based on the power level. So given 2 superheroes, it will say which one is bigger based on the power level. Const superhero by reference S1, const superhero by reference S2. And I'm just going to say return S1.power level less than S2.power level, like this. This is how learning point number 1 is this. And you can do one of these for name, you can do one of these for how many Dragon Balls. So if you want to sort the thing and say, hey, who's got the most Dragon Balls? It's going to be very similar. Okay, so we're going to print out cout d4. And then we're going to sort it. So this is how you use a custom sort function like that to sort. And so we're going to say sort vector.begin, vector.end, and we're going to pass in sort by power level, like that. Notice I'm not calling the function sort, even though, thank you, Commander of Conqueror, very cool. Even though it wanted to add in parentheses there, I'm actually passing the name of the function to sort. And what sort is going to do, it's going to use this function here, sort by power level, to compare all of the different people in the vector and be like, okay, this guy's smallest, then this guy, then this guy, then this guy. So it's going to use that comparison function to compare 2 people and say which one's smaller than the other. And it's going to sort them from smallest to biggest, which I think they actually are already. So that's pointless. So let's do something other than power level. Let's sort by Dragon Balls. How about that? Do you see this? Power level 2, power level 16, 3500, 500. It's already sorted by power level. Okay, so we're going to sort by Dragon Balls instead, just as a coincidence, and it's going to probably try to feed in parentheses. Nope. Okay, we're good. Oh, there it went. There it went. Thank you, Commander of Conqueror. Never change. Never change. Okay, there. All right. And this is going to change from you to Dragon Balls. And there we go. Do you guys understand? So you say sort from the beginning to the end, and then you pass in the name of a function. You're actually passing the function itself. You're not calling the function. You're not passing parameters to the function for it to call. You actually hand the sort function a function and say, use this function to compare everybody inside of the vector of superheroes. And so now it's going to put them in order of who's got the least Dragon Balls first, which will be Bulma. Then it'll be Goku and Piccolo. We don't have any, we haven't told it what to do in case of a tie, so it's just going to be whatever Goku, Piccolo, it doesn't matter. You can get either. And then we're going to have, Vegeta and Goku both have 1. And then Piccolo is going to be last, because it sorts, by default, it sorts from least to greatest. Okay. So just compile the code here. I suppose I should print it afterwards, actually. Okay, there we go. Cout And there we go. So before we've got Goku, Bulma, Piccolo, Vegeta, and then afterwards we got Bulma, Vegeta, Goku, and Piccolo. Oh, that's right. Goku. We added a Dragon Ball, so Goku actually has two. So they're sorted least to greatest by this column right here. Kind of cool, right? Would this have been useful during your CSV data science thing? Maybe. Yeah, kind of would be. Kind of would be. Because you could read in every column. When you parse a CSV file, when I do it, just every column is another entry in that struct. So if you were parsing, some data science thing, this would be like, what was the first one? It was like whether the position level, junior, mid, senior, exec. And then the next one would be like income. The next one would be like country and things like that. And so as you read it in, each one of these things is basically a different column in a CSV file. And then you could sort based on income, or you could sort based on country. And then, it would actually have made your life a lot easier. So sometimes you need to get motivated a little bit to understand why things are so important. Yep. So, excellent. Yes. So you guys are going to have to write sort by name, and it's going to be very similar to this. I'm not going to tell you what you have to change, but one word you have to change. Well, maybe three. Okay. And if you want to make it a little more interesting, sort by species. If there is a tie, sort by power level. See if you can figure that out. So if two people are the same species, let's see. Let's see here. Let's maybe add. Yasai. That's funny. Cyogen. All full-blooded Saiyans are puns on various vegetables. Bardock, yeah. Okay. Where's this power level? Bardock has a power level over 9,000. Okay. Let's add one more Saiyan in there. So Saiyan in there. Sorry, I can speak. We'll just do it directly like this. And actually, you know what? I want you guys to do it. All right, you add Bardock in here with a power level over 9,000. How about that? So you guys get a little practice adding to the vector, and then you get to write a sort by species. If there's a tie, power level least to greatest. Okay. You really want to be fancy, sort by location. Okay, so all this code is in /public/cyan.cc. And you guys have until the end of class. Basically, see if you can write these different custom sort functions, and then make sure you call them down here, right? and then just view the CSV file, so to speak, before and after, and make sure that it's sorting properly. Pretty straightforward. Like not too bad, right? I think this this concept that you can make one variable that has like 5 different variables inside of it. You know, you can just access them using the dot operator. Not too crazy, I don't think. This can get a little hairy when you have curly boys inside of curly boys. You know what I mean? Copy that. It's not a folder; it's a file. Yeah. So just the file is /public /san there, and so just copy that to your home directory or something like that, and then see if you can get that going. Put that there, and you guys got a lot until the end of lab time. If you get it done, then you're free to take off. So go ahead and channel yourselves, stream yourselves coding this, and I will watch over your shoulder and give you feedback as you work on trying to implement custom sort routines and things like that. But that's the end of the recording today. So I'm not logging off, but I'm going to just stop the recording now.